Hello everyone. We have covered till now the control chart for the variables, and we have completed that by constructing mean and the range chart. So today we are going to cover the next one, that is the control chart for the attributes, and we have seen previously that it is of four types: P chart, NP chart, 100P chart and C chart, from which we are going to start the first one, that is P chart, that is a fraction defective chart. So I want to remind you one thing, that control chart for the attributes. What does it mean actually? Because control chart for the attributes are used to achieve and maintain an acceptable quality level for a process whose product cannot be subjected to quantitative measurement but can be classified as good or bad, acceptable or non-acceptable, defective or non-defective, percentage of defective, etc. So basing on that, four types of charts we have. So P chart, it signifies the fraction defective number in a chart. Okay, so it is having the control limits like follows: the control limit, upper control limit and lower control limit. And as we have seen in the X bar and R chart previously, we have to construct all these limits. We have to put down all these limits and to check that each and every observation should lie within these two limits, upper control limit and lower control limit. By this our every observation will be safe. Okay, so by this procedure we can check that whether our process is under control or not, whether our observations or diameters of the shaft, for example, they are under control limits or not. So according to that, we are taking these samples for the next procedure. So this control limit, upper control limit and lower control limit, these are given as follows: control limit is equal to P bar, upper control limit is P bar plus 3 into sigma P bar, where sigma P bar is given by the P bar into 1 minus P bar divided by n root over. So root over, within root over we have to write P bar into 1 minus P bar divided by n, and this expression we are going to see in NP chart, 100P chart. Only modification we are able to see in that control limits, because all these control limit formulas are similar, more or less similar to all these charts, that is P, NP and 100P chart. So there is a slight difference in using that formula. You can carefully see that. So this is sigma P bar. So what is P bar? P bar is nothing but mean sample fraction defective. We are in the next slide, we are going to see how to calculate this P bar. Now sigma P bar, it is the standard deviation of the average proportion of defective. So what does it mean by standard deviation? So standard deviation is nothing but it is a measure of the dispersion or spread of a set of data from its mean value. It measures the absolute variability of a distribution, and the higher the dispersion or the spread value, the variability is there, and the greater is the standard deviation. If there is a higher value of dispersion, then there is a higher value of standard deviation, and it is depicted by the normal distribution curve we have discussed previously. Okay, so just remind that standard deviation is nothing but a measure of dispersion of a set of data from its mean value. Now going to the next one, we want to see how to calculate the fraction defective value, that is P bar, average of fraction defective or mean fraction defective. So for the calculation purpose, we have to take sample number. This is 1, 2 up to capital N here. Now the sample size is constant, for suppose it is small n. Number of defectives, let's suppose number of defectives is nothing but D1 for the first one, sample number 1. For the sample number 2 it is D2, and for the sample number capital N it is capital DN, D subscript capital N. Then we have to find out the proportion fraction defective. As the name indicates, fraction defective means it should be in a fraction. So P1, we are going to find out P1. P1 is nothing but D1 by N. So D1 by N is number of defectives divided by sample size. Let's suppose, for example, if for the sample 1 there are number of defective is 4 and the sample size suppose it is 10. So 4 by 10 we are getting 0.4. It is 0. So it is 0.4. So like this you can find out the fractional defective values for the sample number 2, for the sample number 3 up to sample number n. So Pn will be d capital N divided by capital N. So the mean value of the fraction defectives will be as follows, that is P1 plus P2 plus P3 up to Pn divided by capital N. So just put down the value of P bar in these control limits and then you can find out the value of the control limits. Okay, just put down the value of this P bar here. This is P bar. Okay, so control limit is P bar and upper control limit is P bar plus 3 into sigma P bar, and sigma P bar is nothing but P bar into 1 minus P bar root over. And lower control limit we are only changing the sign minus here. So P bar minus 3 into P bar into 1 minus P bar divided by N, it's root over. So this is all about the P chart and how we are going to calculate. Now the next chart is NP chart, that is the number of defective charts, and its control limit is given here. So for determination of the control limits only we are changing a value that N, we are adding or multiplying a value capital N, small n here, because this is the only change in from the previous values of the P chart. So it is NP chart or number of defective chart here. So upper control limit is nothing but NP bar plus 3 into N into P bar into 1 minus P bar root over. So upper control limit is NP bar plus 3 into NP bar into 1 minus P bar, and lower control limit is NP bar minus 3 into NP bar into 1 minus P bar. So this is all about the two charts, P and NP chart. The other two charts will be discussed in the next video. So that's all for the day. Thank you.